3.1, number 21. We have the function f of x equals 5x plus 4, and the location a equals -1. Find f prime of a using what they're calling equation 3.3, which is this. They have it written as m tangent, the slope of the tangent, which of course we know that's the same as this, right? Slope of the function, which is the same as slope of the tangent at a. So m tan will equal the limit as x approaches a of f of x minus f of a over x minus a, again the standard difference quotient. So just plugging in these values here and the function, and then simplifying is the main thrust of this. So we'll have m tan equals limit as x approaches -1 of f of x, so I leave f of x unchanged, 5x plus 4, just put that there to accentuate it, minus f of -1, so f of -1, if I plug -1 in here, I'll get -5 plus 4 is -1, back again it turns out, -1. Again, this is not the -1 of the a value. It turns out that when I plug the -1 value for a in here, I will get back out to -1 again, over x minus the -1 value for a. All right, so now we just simplify. We'll have 5x plus 4 plus 1 is 5x plus 5. 5x plus 5, and the bottom is x plus 1. Now we see that removable discontinuity for this function of x plus 1, right, the location of -1. So we'll take that away through factoring and canceling. Again, this is all because all of these derivatives are always inherently a 0 case. So quite often there's a cancellation of factors in some way to remove this denominator heading towards 0 here. We can get rid of that in almost every case, especially in textbook problems. Something like that. And then we get the limit as x approaches -1 of just the number 5, and of course the limit of a constant is itself. So there is f prime at -1.